the go live button. Wow, and they changed nothing else about the interface. I wonder how they could make it worse. I'm sure they'll find a way. That was very cynical. YouTube doesn't really have a very good track record. Alright. Short intro. Gotta get right to it. Okay. So, what's the idea? What's the big idea? So the idea is that in Mashta branch over here, so okay, it does things. So how the serializer works is it iterates over all instances in the DOM and iterates over all properties. So every time it finds an instance, it's like, oh, I found an instance of this type. So that's like part is one type. There's other types in Roblox. Maybe text box. So these will all be separate lists. It'll have a bunch of these objects, and they are in this guy, which is a map. So these instances will all be the same class and have the same set of properties. And then inside, it makes this, and this thing is just like information about a particular property. How does it serialize? Is there a migration that needs to happen? So after it goes through and checks every instance, every property of every instance, then the next thing it does is do it again. It iterates over every property of every instance, but in a different order based on this list. Well, it's actually the same order, but repeatedly. It repeatedly grabs properties out of the instances. And that's the optimization, is that it's doing the same, it's duplicating the same work. What I should be able to do is make it so that instead of storing a list of instances here and having to iterate over the properties in the instance, I can have a vector of reference that are used. And the properties are already pre-extracted. This is the problem zone. So it'll have, yeah, this thing is kind of wacky, a list of pre-fetched properties. Well, not fetched, references to the values of the properties. So it's this is kind of crazy. I probably should think of a better way to do it. But this is the best. This is the best I got so far. So it's a enum variant vector of references to a specific type. So that'll be like bool is a list of bool values. So yeah, it's like this. And then C-frame is a list of C-frames. But it's references to C-frames. So it's just collecting pointers to values throughout the file of a specific type. So it doesn't have to check the type again, although it is doing a lot of type checking. So can you see this? Yes, you can. The red zone here. This is the last problematic code. Probably I'll have non-compiler issues with this code. Because the order that it writes the properties is very specific. So I'll have to either exactly match the existing behavior or prove that my new behavior is better somehow. And deterministic. I'm going to go for the former first. I'm going to try to exactly match the new value, or the old way. Wait, what the hell? Wait, what? It's the same code twice. Huh? Excuse me, what the hell? Okay, I think I understand. So that means I need like oh, this is just making it. Okay. I'm gonna put this around here. How to do this? And then or else. Oh. Okay. Yeah, I clearly was not thinking very hard when I put that together. But like, I meant to do that. I was just kind of like moving code where I thought it should go in a general sense and not like figuring it out. I was leaving that for today. The whole figuring out part. So what I need is I need property data descriptor. This properties get is that canonical name. I don't think so. Is that not a real field? Oh, I can't find the value. Huh? Oh, it's not option. That can be arranged. Just okay everything. He who. Oh, is that gonna like format weird? Whoa. Nope. It's chilling. Okay. Or else. Or else. What the hell is this doing? Default value. You got the if statement at the bottom of the pile of for loops. Just to make sure. This should be an object. This code shouldn't exist separately. Like these lines of code should not exist separately. Or maybe it's only here. No, 3 of 8. Ooh. It or cloned. I guess it's an arc. Huh? Hell is this? Add instances. Self. Serializer state. Why is it? Oh, it's called once, isn't it? Okay. Oh, it's a hash map. Okay. Still, that seems like not the right data structure because they're like inserting 0. But whatever. Who is this? Type result. Okay. This guy needs a question mark. Massive. Okay. Stuff. Okay, doing good, doing good. So I gotta figure out what I want with this thing. I need to map two values. So this is an optional value. Oh. And this is calculated from that value. Option. This is an optional value. Oh my god. Can I go like... I mean, I can, but I don't know if this is the best way. None. And then default value. I need to work off of that right here. But then go again here. Okay, I think that does. I think I just replace it twice. None. And then in here, I do like this. This guy. Else. Prop name. Surely. And then... So I'm replacing the code. Find property descriptors. Decode. Okay. But it is red. Oh. It's referenced. This. There's a lot of flying parts here. Moving parts. This is okay. We gotta match out the name. So I believe that's kind. Match PD.kind. Wow. And I probably can't just yoink that, so yeah. Okay, let's look at the old code. It's over. So we're looking at the code that's deleted. Mwah. Okay, so canonical name is equal to descriptors.canonical.canonical. Fananical. I believe that's from find property descriptors function though. What? What? Is this like doubling up? Okay. So if what it finds is a migration, then it needs to say that the name is the migrated property. Buh. And it also finds this information. Oh, this is this part. This code is a little bit wacky. Okay, so the name might be a migration. Yo. But if it's not, then it is just the guy itself. And that's the full thing for canonical name? No, there's another one here. God damn. Okay, I see, yeah, okay. Damn, that's a lot of crazy stuff. So this just like clipping. And what happens in the none case? Okay, so they're just ignoring. Bro. This is annoying. So, I believe it would be good to do this in here and then do the rest. So I do believe I can go like this. Default value equals that guy. God, there's so many moving parts. Really hard to keep them all in my head. Well. Mm. Mm. Okay, so this insanity is happening. Match. Or I guess this is fine. Huh? Should be like that. Holy, okay. Oh god. I guess that's not terrible. It is kind of terrible. Okay, so then What's up? Seriously? Oh, option. Oofy doofy. Who did this? Oh, it was me. I did this. Okay. Is there... I don't know. I believe these guys come out of here. But then... Oh. Uh, 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 uh. Okay, I think I see a problem. Why is it so loud? Okay, I gotta open the window. What's the problem? The problem is that there is no value to base it on. It's all speculative at this point. Oh, wait. No, I think I just need to pass the property in. I think it's there actually. Okay. Who said this? It's right here. Get or create. So, bada bing, bada boom. Instance properties prop value. Bada bing. So this is a reference to variant. Yeah. So I believe it's got to have this example value. Year. Okay. For real. For real. And then this needs another Do we need that outside? Maybe. God, what a mess. And then this guy, it goes like this. It goes like, oh, canonical name. That's just prop name. I'm gonna actually write it into variables here. So boom, 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 and we go like, boom, 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 boom. Let boom, 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 boom equals to boom, 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 boom. Year. Okay. Canonical name is just prop name. Okay. The serialized type is just sample value dot ty, and then year, none. None. Yes, 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 yes. Okay. So I named them all here. So it's obvious what's going on. Ish. Oh my god, bro. And then so that I think that makes sense. And then now out here there's that guy. Instance. Not bad. Self. Who is this? It's a type info. Type info is class descriptor. This is interesting. There's a lot of red underlines. I'm doing good though. Oh. Hmm. Hmm. No. I do believe this is another one. Hey, how's it going? I'm making a mess. Oh, and then now it doesn't show up there. All I really need here is type name. So I'm gonna just take that as a freaking argumentative right here. Dumpster, I think. Dumpster fire? Ha. So boom, boom, boom. And then on the call site, I do like this. Instance dot class as stir. Sigh. Wait, what? Wait, what? Wait, what? This code is duplicate. It's duplicated up here. What if it only existed once? Look at that. So this is when you make a default value. And then this is before you make a default value. Ba. Uh. 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 Note, this is duplicate code that is also in, boom. I'm gonna note that for myself right there. Okay. So this thing is not doing the right thing. So we need actually this guy as well. Year. Oh my. Okay. What is up? Oh, I see. It's like, oh hey, what's up? Okay. I see. Okay. If let some else. I see. Okay. Prop name. Sample value. If there's no property descriptor, then there's not much you can do. Ooh, those red underlines are getting smaller. Default value. Okay, most of it is to-dos, actually. Okay. So what happened is, we found a property descriptor. Hold on. A migration should always happen onto the same class, shouldn't it? So if I do find map and return the class, then I don't have to superclass iter again. It's not that cheap. It's not that expensive, I guess. Oh my god! It's just like a little bit ugly. It's way better than it used to be. It used to look like this. Oh no, it's find property descriptor. Oh, I didn't delete the function. Oh. Wait, is that in reflection? No. There it is. So it used to look like this. I think it's gonna end up looking like that. So it's like checking the superclass. But okay, the thing is, like, if there's a migration, oh, it doesn't do that. Okay. What the function is this? Yeah. So this doesn't have to walk. Because it's like, oh, yeah, use that guy. Oh my god. Like there's just a 0% chance this is gonna work the first try. The data structures are nice that they exist, but they don't prevent representing invalid states. You got to make invalid states unrepresentable, and like it would be pretty nutty to get, excuse me, all of this through my head and like figure out how to make it impossible to use wrong. And like it might not even really be doable because it's just reflecting C++ code, and that just does whatever. Serialization. Uh, um, unwrap. Bro said unwrap. Five yield. Hmm. 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 Totally different from what you were working on yesterday. Yes, this is what I actually meant to work on yesterday, but I was shown something interesting, and I went, "Ooh, shiny," and I did that instead. So, okay, I need this stuff. Surely I can just call the function, right? I just go like, oh, give me that function, boy. This guy. Find property descriptors. Oh, goobity goobity. I see. It's a bit of a, okay. So I'm at this level-ish. It's not quite what I want. Oh my god, bro. So I think that it should take this as an argument. Wait, equals. True, I guess. And walk up, and that should be like a function. It's this. This is that's it. Return. Does this ever not return? Match. Return. Is that? Does it ever get out? I mean it must, because it goes here. Oh my god, bro. Oh, it's the else case. Okay, so if there's okay. Yeah, okay, so this is like, I think this part is what I want as like a separate function. And then the other stuff is just like iter, walk, class tree, blah blah blah. Yeah, okay, I'm thinking two functions. One finds the property descriptor, and one gets the gagri from here. Okay, so it's like, they're the same kind of function, but get. Does it ever need database? Descriptor properties get. No, okay. So it's gonna go like get property descriptors. None of this. That guy who you do is yes do that do is that dude. Oh. And then do we smash it in as it is property name? Yeah, I think so. I think it just goes. I think it just goes. Descriptor. No way. No way. And then basically this guy is eater right here. Eater, and then this guy return get double what? Who? Oh my god. You good? You good? You good? You good? Return. I think I got it. Okay, so this is like, I wanted that. I wanted this function because like I already got those food, but I don't got to do like this. So I think that so I think that yeah, it's literally I do believe gobble I think this is a map actually. So actually I can just steal my code from right here and then absolutely shank all this code. It's just gone. Literally, it's gone. Watch this, watch this. Boom. Map. Boom, wait. Find. Find map. Surely, right? Can you imagine? Okay, so then that's like that. Who did this? What is that? Who did that? What is that? Property descriptor. Okay. This is gaming. Check this out. Boom. And then boom. 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 Wait. Expected option unknown. Found. Huh? Oh, wait. No. What? Oh, second. Oh. Okay, I got it. Got it. Okay. Dot map. Class prop. Oh, it doesn't. Okay, who did this? What is that? Okay, so this function is expected to take a single tuple, but it takes two distinct arguments. Fine. My one-liner can die. Go die. Okay, I still need the old code bit. Little itty bitty old code. Okay, who is okay, it's right here. This one. We do like this. Class descriptor. I guess we can have this line. We can say class descriptor like that. And no mutable. No. Option. Find map. Okay, so that's optional. So we want and then. Okay. Okay. Is that the same? Look at this. All that code is now that code. Super classes iter. Let's go. Okay, I don't know if that's actually equivalent though. Okay. Minor refactor. Well, I guess most of the code goes up here, but like I was pulling out that portion of the code. I guess I don't actually need to refactor this. You know what I might do is like write it next to it or something. Okay. Do it be doing like that? Get property descriptors. I think you're done. I think you needed to like grab it and then snap it instead of like, because I could call this function directly here, but to match the semantics of the original code, it only snabs it after it grabs it. And it just keeps walking, or it stops walking when it snabs it. There's no non-return path here. If there was a non-return path, if return none meant, oh, keep going, then it would be in that loop. So I think I actually matched the semantics exactly with like 5 lines of code. It's kind of a 2-step process here. Find property description. 2. So it's like this guy goes here, and then this guy goes here. I mean, that's not the most helpful comment. So if I say 1, 2 like that, like then it's like, oh, that's 2 steps. Okay. How much money did you make both of your games? I don't know. It's been more like income than like, oh, you got $200 billion. You don't get any money anymore. It's more like I make $2,000 a month or something. So it's like not outrageous. It's like a minimum wage job that I don't have to work at. So, hell yeah. It's my code is doing a minimum wage job for me. Okay. The code. The code. It's the code. The code. Hire an AI to code updates for it. Ew. I don't think I'll ever do that. That's not true. I shouldn't say that. Certainly not right now. Oh, no. Oh, I'm trolling. Wait, what? No modified lines selected. What was that about? Is that the full bing in the bong? I might actually just pull this outright because like this is separate. Look at how nice it is. Minus 81. So juiced, iterators, so juiced. I love iterators. No way. I'm gonna blast a space right here. Alright, what's going on here? What did I do? Oh, I freaking... This is a big hunk of code. Okay, so I do believe... Okay, so this guy is like... Oh, this is it. This is it. Ah! It's gonna get me again. It's gonna get ya. It's gonna get ya. Okay, I TB weeby db ubi aba gaba taba. Oh, shum. No. Shum none. Num. Shum. It needs it. I need that. The class. I need that. Get out of there. How do you do that? I know how to do that. Okay, it's gonna go like this. Class prop. It's kind of cringe, but whatever. class. Oh, it's dot map. Dot map. Prop. Class. Prop. And then this is now. And then we go like. Any news on your clean room? No news. All right, I'm gonna use you as a shield and say CLV wants updates. It's not me that's pestering you. It's actually it's actually that guy. How's Refactor? Quite good. This is quite good. Oh my god. Okay, so this is what. Okay, here we go. Here we go. We're gonna grab these guys. Give me that, and then we're gonna go like yo. We go. Oh wait. Dot, and then. And then unwrap or and then and hello please, hello me, hello class prop, and then you get property descriptors, me and you. Oh my god, bro. Unwrap or else. No, map or else. Map or else. Okay, maybe I'll just match it. Cause like it's getting too crazy. Some descriptors equals to else doobie doing, and then descriptors. Whoa, okay, we do like something. I do something. Something. I am doing something. What am I doing? There's numbers here. It's not numbers. I'm making no sense. Do the thing. Yes. Okay. Format. What do you want? Cannot find the value property descriptor. You're lying. What? Okay, it's lying. Yeah, okay, it was lying. Wait, no, it's here. Property descriptor. Oh. Ow, it's this guy. Dot map. Class prop. Oh, I can just go like we don't care about you, and then prop. Shirley, are you okay? What are you? Okay. Shirley. Come on, man. What do you want? Oh. It's not a struct. Ah! I hate it when it underlines the code. Okay, do the thing. It's the thing that needs to be done. We need to get the category name, serializer. So we have the descriptors. We just go like, oh. Descriptors dot canonical dot name dot into No. As ref into, and then serialized name descriptors dot. Option. Uh. uh Why? Why? Lies. What do you mean option? What do you mean option? What? Why? Oh, because it might not serialize. Okay, but then what do you do then? Result. Error. Do you just did it's huh? So does it not make it if it doesn't serialize? In the old way, in the olden times, God, this just drives me nuts. I'm thinking serialized name doesn't exist in the property info. It's variance index or something like that. It's like, oh, oh, use number 4. But like, oh, no, that's not true. Yeah, no, that's not true. Yeah, okay. Yeah, no, okay. I'm close, but do I need another goddamn else case? Like, goddamn, bro. I'm like passing it out, pass it out, pass it around. Ugh. So close, but so far. All right, I'm just gonna cheat. I'm just gonna like, I need to make this go away because it just drives me insane. Thank you. Okay, so these are both wrong. This is actually like serialized type dot data type. Da. Actually, you could totally have a function that does that. Because on the old code, it was like, oh, yeah, oh, and then isn't there freaking this guy now? Oh, string. But that's literally the same, but it's, oh my god. Yeah, this is a mess. And it's only partially my fault. God damn it, why is there an else case? That's how it was, right? That's the old way. God damn it. So somewhere in the shadows. Where's the old ways? Right here. Okay, yeah, that's how you do it. Cool, 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 cool. Ah, I can't do that. It's not allowed. Unlucky. Okay. Um. Unknown. Okay, we want this. Q. Okay, so this is wrong by a lot. So the old way, serialized name as ref into. Okay, so basically, otherwise it just gets the sample. Okay, I'm starting to think that passing out is like it. Yeah, just we'll just like let bind them instead. Pass it out. Hold on. Are you changing? Yes. Okay. So I'm just gonna go. I'm gonna do the differently here. Okay. So we got all of y'all. Let semicolon kind of, but not really. So then yeah, no, get out of here. No. Do not do like this. It's if else. Oh. Eh. Like this. Oh, we don't need we don't want this. And we also don't want this. And we also don't want this. And we don't want this. Who's doing stir? What are you smoking? Oh, give me this. Oh, jeez. Oh, fair. Okay, that should be a little bit less terrifyingly bad. Expected stir. What are you smoking? Why is... Oh, it's trolling me. Okay. Oh, this is doing let. Oh, I'm stupid. Okay, there you go. Okay, that is rather less insane. Oh. Huge. Okay, so I literally just go like this, and then these guys are done. Literally. Okay, that is a much smaller mess, but it's still a huge mess. What the hell is going on here? You know what? I don't care. So yeah. Alright, let's get on to the... What? There's no errors? I totally expected there to be like biochecker errors. Wow, I'm a good Rust programmer. Holy smokes. There's like, okay, how this... Did I get it? I got the copy. There's like multiple levels of compilation for Rust. And like, there's like the syntax error level, and then there's the... type checking level, and then there's the borrow checking level, and then there's just like warnings. So you don't get to see the lower level of errors until you fix the higher level of errors. And I went straight to the bottom. I had already figured everything out. That's why I'm like, whoa. This is still wrong. The deeper errors. Yeah. Yeah. So this is now like if let sum serialized. Is this a reference? It is, okay. Equals to this dude, then do this, otherwise do that. Boom. 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 Oh, wait. And then this should complain that you have a path that don't be doing like that. Left uninitialize. Nice. Okay. Correct. So else like that. What the hell? Okay, I see. Okay, it's like this. I got the wrong one. Okay. Ooh, okay. So now that issue is settled. This is what made me think I should just be doing let bindings instead of implicit return. Okay, so I have code that compiles, but there is a 0% chance that it will function meaningfully. And I can demonstrate that like this. It should just absolutely spam errors out the wazoo. Oh yeah, there's also those things. But it does compile. We've reached the first step. Oftentimes in Rust, this is the only step. If all of your data you can't represent invalid states with your data types, but that's not the case with this. So failed. 53 failed. Yeah, 4 passed. Damn, passing 4 tests. Those are probably irrelevant tests. Oh, serializer. Huh. They're not irrelevant. Damn. Fight the compiler until it works, then it'll work for sure. Yeah, that's the usual path, but that's not what's going on here. There's a bunch of ways to set it up invalidly. Damn. Okay, so I actually reached. Okay, actually, this. This is mutating this object, and I don't really want to pass that mutable state in here. I think that's silly. Okay, so it fails the tests, but what about the benches? Um, yeah. Okay, so we're gonna go to Bada Boom, and we're gonna run bench. You stop running. Okay, so I don't know what to expect. It's probably going to miss a bunch of work that needs to happen in some cases, but they might be rare cases. So we might already get an accurate benchmark or a close enough benchmark. I don't know. So that's why I'm doing it right now. So these results are the baseline results. We don't care what the difference is because I don't actually know what the previous benchmark was. We care about the next benchmark run when I run it on the refactored branch. So this will take like 2 minutes. Do you play Surf now and then? Not really. B-Hop, I am kind of back to playing that pretty frequently, pretty regularly. I open it up every other day at this point. It really needs to be easy to open. It has to open in like 5 seconds. Otherwise, I won't play it. Because it's like, I just play it on a whim. That's like one of the things I like about the Strafe client is it just opens and there's the game. Instead of like boot Windows. Ugh. Windows. Amazing. Okay, so there is our initial baseline. And here is the after. So what I'm hoping for is that the serialization speed is significantly faster, but it might be wrong as well. Okay, that makes sense. Okay, I probably should have tried this before I ran the other benchmarks. I guess we have the baseline now. All right, I'm gonna resume my encoding. Well, there is a lot of work to do here. And it's like mental gymnastics the whole time. I kind of wanted just to get to this point of like it compiles. Honestly, I want to submit this as a PR. Hell yeah. I wonder if it's faster. Probably not. I could this could totally be a separate function. I think. Oh, dude, you could question mark this because it's optional. Yeah, no, this is that can be made better. Hell yeah, brother. Okay, hold on. Think. Hold on. Yeah, I'll bust it out into a separate PR. How many? I have PR1, PR2, PR3. I have too many pull requests. So we're gonna cherry pick the comment to start, and then I'm gonna continue to edit it. So I'm gonna do let these guys equal to that guy. Question mark semicolon get property descriptors. So now it's clearly a second step. So then I also want Uh, descriptor. Uh, you can make it a constructor or something, or like from into. It's okay. Yeah, so find property descriptors is finding it, and then get property descriptors is getting it. Or make, maybe it should be make. You could also do property descriptors new, or something like that. Yeah, because it's literally a constructor for this guy. Then now this is new. This is uh Do we really want none sum on this? Oh, I see. Okay, so this is like what I mean about invalid states are represented. Where you have these things that are like pointing to each other with strings, but there should be some sort of alternate way to represent it that you can't make it wrong. Okay, so I like that. Yeah, so it's find. Find. If the find fails, oh no, we didn't find it. But then you also have this cool function for cool people. Oh, hey. You can totally just have these be stirs here. And then that's gaming. That does change this code though. So you can do this. Uh-oh. As start into big oof. No need to make it a uster there. Interesting. I wonder if that also makes sense here. Because I only use once. And we're doing into. Why? There's no need to do into. String. Okay. Remove unnecessary user creation. Okay, so let's see if it passes the tests. Let's see if it passes the tests. It should be the same, but it's entirely possible. I'm dummy. Cargo test release. It shouldn't benchmark. Ooh. Ooh. That's a good drop. Hey, we passed all the tests. Okay. Bench. We should be able. It should bench to the same standard. There shouldn't be any difference. It actually might be a little bit faster because it doesn't have to make these unnecessary Eusters. Oh, I see. Prop name, class name. Okay, so it never uses class name as a Euster, but prop name might be a Euster. So I think that's better like this. Okay, that didn't work out too well. So this guy happens, sometimes. Probably, okay, what is going on? Find property. So if there's no descriptors, then this is like a cold path. This is like an invalid property. I don't know. That's not necessarily unnecessary here. So, okay, wait. Prop name. There is a case where it's already Euster right here. This does happen. Prop name is already a Euster. And then, what the hell? But it's an invalid property. Okay, how did we do? Should be like exactly the same. Oh, it's the unreliable benchmark. I don't know. It's already there. Serializer state. So like this guy doesn't care. It just uses stringies. But this guy does care. So yeah, no, this guy cares. Euster. The class, I believe the class name doesn't care actually. Euster. I do believe so. Oh, this guy is back to this. And then yeah, okay, so this guy doesn't care. Doesn't matter. Yeah. So what are we looking at on here? So yeah, find property descriptors does not care. Find canonical property, however. So like it's true that it's already a uster there, but we don't need it inside the function of this might be a problem. Wait. Oh, is this somewhere else? Oh, it is somewhere else. Oh, I see. Deserializer state. Okay, we're chilling. Um. Okay. I think it literally doesn't matter because all of the arguments are already the correct type. So I could just like revert everything here. Oh, no, this one actually stays. Those are actually part of something else. Okay, something is sussy here. Okay, right, it's all rolled into one. Yeah, okay. So I don't touch the find canonical property function signature. It's fine, it doesn't matter, but all of the calls to this do matter. Yeah, okay, that's good. Yes, okay. All right, this is juiced. We got -9. That's like powerful. I'm very powerful at programming. Power play. Okay, there was a space here. Oh wait. Come on, man. Really? Okay. Whatever you say. Come on. Okay, trying to make the diff small. So, yes, I'm gonna fix the comment here. So, find a class descriptor which knows about this property name. Period. Yes. Yes. Hell yeah, brother. Gaming. Just a slightly better comment. You hear? Sick. So like another thing about this is like the class might not actually have the property descriptor. It might not be there. So you can call this function incorrectly with incorrect arguments. The whole thing is really up in the air and dynamic. So it would be a big challenge to refactor it enough to make invalid states unrepresentable. I have no ideas for how to do that. Cool. Good. All right, what about that other function? Find ding dong from ding dang. I think that's chilling. Good God. Unwrap. Should I do it like this? Let prop equals this question mark and then return sum. Does that make more sense? Kind of. Okay, that does make more sense. Yeah, okay, so if the prop exists, we return both. Instead of like dot map. I think that makes more sense. Cool. I lose some lock here. Lines of code. It's minus 79 plus 73. I want to minimize the comments to make it look better. Can you believe it? 5 lines of code. For that giant loop. Biting my mustache. Anyone else bite their mustache off? That is sick. All right. Come on, man. Let me through. Really? I changed the... Okay, that's why. Okay, so we want the before and after. God damn it. Okay. I'm going to save this because rebases can go wrong. Squashes. Alright, what do you want? Alright, you want like this with this. Or wait. Right? And then continue rebase. There we go. Okay. And then you want this with this. And these are the same. And this is like that. Huge. Okay. Wait, what? Oh. Okay, comments minimized. huge. Okay. Is my PR3 posted? Yeah, this is PR3. I was gonna hold off on this guy. Or like no cow as well. Yeah, this is kind of separate. I'm not so sure about this. Lazy static. Should it be called default or fallback? Oh, it's fallback default. Oh, okay. It's not the prettiest code, but like neither is this. Found. Buh. Const. Let's go. Yeah, so I can put this into the prerequisites and then rebase it. I think I'll give that a go. Nice, easy. And then this guy, not so easy. Oh boy. What up? Find property descriptors. Right, that code, it does not exist. Whee! Yeah, we want the cool one instead. This is like doing the same thing. So we want the cool one. does it know? That's kind of juiced. It knows not to insert this bit. Okay. Okay, so the diff here should be just this stuff. And maybe a miscompile. Cool, okay. Little fix-ups. Yeah. So then we got function that doesn't exist. New. No way. And then this is the code. Okay. So who wrote this? Which comment? Okay. I can just leave it here. Yeah, so there's the core change, and there's also little bitty bits. Yeah, okay, that makes sense. Can we grab this guy off? Okay, cool. And it builds, right? Okay. Cool. So that's a rebase. So now I have 4 prerequisites. I keep like I don't know. Is that a good idea? I think that is a good idea to like split out bits that would be good standalone changes. Like this destroys lines of code, which like for the same functionality, that's always better. Always. Unless it's harder to read. Or some other, like there's no, it depends. I wonder if there's any like optimizations that can be made here. Number 4. So find property descriptors, find all references. Does it ever know ahead of time? So this knows the class. So it's re-looking up a class it already knows for every property. Yeah, that guy can actually. Like, that needs a hash. I think this can actually help. Get or create instance dot class. So this guy contains optional. Oh no, it's down here. Okay. Class descriptor. So if it didn't find a class descriptor, you're not gonna find the descriptor. So this is gonna be and then type business. Like, what even is this? Isn't this like same type of migrate? New property name. Okay, what's the other reference? These one. Do we know the class guy on here? Who did this? Type info.type name. We do. We have the class descriptor here. So we could, this could totally get optimized. So this guy, instead of glass name, can directly be this guy. We can like surely. Okay, who's the third one? Who did? Oh, it's inside. Okay, no, this is chilling. Okay, yeah, totally doable. Okay. Is that here? No. It's here. Give me that. Where is it? So this can instantly die if there's no guy. Oh, CLV update. My sources are saying it's a mega convoluted operation. It's a delta encoded indices. Wait, that's exactly what I was trying to do. They're figuring it out. Database. So we only need the database. Oh. Can you give me this? Okay. So we want like a question mark thing here, type business. Oh my god, bro. Uh, This guy. Yeah. Oh, what up? Oh, it's wait. Is it option? Oh. Uh, why is this in my recommended feed? What is debugging? Am I saying debugging anywhere? Did I say that out loud? Are you a programmer? I don't have much context. So I'm working on a Rust library that decodes Roblox files. It's an open source library, and I'm not a main contributor. Sorry, I mean, there's a lot of exchange of information that has to happen in order to get up to date on context. Communication is hard. No worries. How should I do this? So, it would be nice to have an if let here. And because this only needs to happen if there is a gip. And this can be an else case, but it has to be an else case for both. This would be, yeah, so maybe if let chains would go hard here. Yeah, I think it would actually. If let chains were only, were they stabilized? If let chains reset. Stabilized version. I swear. Oh goodness, what website is this? Okay, I don't know. I thought it was stabilized in a recent version, but like this doesn't use a recent version of the compiler, so I think it would go hard here though. It might be a bit messy, but it would be able to reuse the same else case easily, like this is doing. But like the problem here is that this guy needs the class descriptor as well. Actually, I can do that. Roblox only modeling, no programming knowledge, no idea what you just said. Okay, context has been transferred. I now have the necessary context to communicate within my brain. Roblox modeling. Yeah, so I'm working on programming basically. That would probably be the best way to describe it. It's I'm trying to make the tooling for Roblox files within the Rust ecosystem better. I think I can make it better, faster, stronger. So I'm working on that. Oh. I guess I can use this guy like this. Question mark, then return some descriptors, and then that's something, and then we can grab this from here. Blah. And then we have this here, and I can pass it into here. Reusing it. I don't have to look it up twice. Oh my god. But wait a minute. Does it need to walk though? Hold on. There's no way it needs to walk, right? Because it's already walked here. If it's migrating, there's no way it needs to walk again. Look up the progress it needs to migrate to. Like that's totally always gonna be on the same class, right? Normal 3D modeling, totally fine. Programmers and modelers work together to make games. You don't got to worry about all this. Someone else's job. Unless you do want to worry about it. Maybe it's interesting. I think everyone can do programming. It's like very hard. So you have to really want to learn. Good. So this guy, yeah. So this is like pulling out the internals of the function to optimize it to avoid doing relookups and more like superclass walks. Or like this is a cold path, I guess, but still we already looked up the information, so it'd be wasteful to look it up again. Did I already fix the other bugs? Class name. Huh? Oh, it's like this. Give me that. DE. Oh, it's an elided lifetime. I might be able to get away with that. Ooh, maybe not. Oh. Interesting. Okay. Class descriptor should be around here somewhere. Yep. Okay. Import. Yes. And then type info that if some property. Yeah, this is totally if let chain material. Hello? Huh? 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 Oh, it's a deserializer state. It's not. Oh, what the hell? It's a different thing. I got owned. Crap. Is this possible? Type name reference. Type infos get valid type ID. Decode chunk. All. Deserializer database. So is it creating this scuba here? Decode prop chunk? No. But like once again, we can save lookups. Like this is already done. Using more memory. What language is this? This is Rust, the Rust programming language. So Roblox itself is written in C++, and Roblox games are written in Lua. So this is kind of irrelevant. I like Rust because it's a great programming language, and I'm trying to sort of move away from Roblox. But I've kind of gotten sucked in to working on this because I think I can make it better. And so it's sort of a, if I make this better for me, it also makes it better for everyone type situation. Everyone who's using this library. And I think I see another optimization. Oh yes, optimize. Type infos. Oh my goodness, what? So that's the deserializer state. Type info, there's no... Yeah, so I have uncovered an optimization by... God, it'd be so much easier to fold it into this function and provide an optional value. Yeah, but like this, it'd be good to have on there. Can database. So then I can. It's okay. It's doable, but it would change the way the code works. Ooh, okay. Let's call this. Right. I have to unwind this stuff. So basically, I just kind of yoink the internals out of here. Basically. Because the migration should be using the same. Yeah, there we go. Now we're talking. So then descriptors equals a new guy. Property descriptors. New. Class. Prop. Question mark, and then we return class and this. Wait, what about properties? I don't think that matters, right? So this is it should take a happy path here. Yeah, so I think I'll make it explicit. So assume that the migration will always be directed to a property on the same class. So all we need to do here is go like, hey man, prop migration. So it's like new descriptors is an optional value. So it's like, yeah. So it should be like still this. New descriptors equals class descriptor dot. So this is it's a bit different. It's like the class descriptor which contains this property. It's a little bit different. I may just call it superclass descriptor. Because it's like slightly different. Oh, who's this? Property name. Okay. Good luck with your project. Thanks. Okay, so new descriptors, super duper get new property name like this. Esther. And then, oh geez. Come on. New superclass descriptor prop. And that should do it. So that reduces the lookups. Assume that the migration will always be directed to a property on the same class descriptor. Oh, dot get. So true. Very true. Very true. So properties. Hell yeah. So I've like pulled a magic trick out of a hat. Fair. To like reuse a lookup. This is a bit not great, I must say. It's a eeny weeny tiny bit better. Serialize and deserialize better. Find property descriptors? Nah. I don't do that. We don't do that around here. Around these parts. Okay, so then this guy will also be holding like database references as we go. Hee. Type info. To avoid the old relookup situation. Oof. Database. God, I hope this gives me some performance. What do they say on this guy? Okay, cool. Yeah. You good? Okay, so get map unwrap prop. So this is doing the lookup right there. You got it. Class descriptor. Class dismissed. So map unwrap. Oh boy. Map. Map or? Do I want map or? I think I want map or. None. 0. Class dismissed. True. Very true. Oi. Some. Okay, so we have an optional class descriptor, and why don't I name it fully? So you can see it's already doing the work here. It's already looking up the class descriptor, and then it looks it up again. Don't do that. Just write it down and then use it again later. Don't do that. Okay, so now we have the problem of it being an optional value. So property equals canonical property. So yeah, this is literally like if let chain business. Find canonical property. Type stuff. Does it have to walk? Decode prop chunk. Does it have to walk every time? I don't know. I think so, because like each chunk has a unique property. So good database. I need this to be like, if the class descriptor exists, then you can find it. If this class descriptor does not exist, then you can't find it and don't bother. Type. Situation going on. You hear? So is that a map? What is that? Option. No, that's an and then. Okay. Crass and then. Crass descriptor. Good. Seeing is hard. And then find and then check and then it works. Super ugly. Let's go. Okay. So that might do it here. Oof. So now it's reusing the class descriptor. It has a jumping off point. Instead of needing to look it up from scratch, which involves hashing, which is slow. So we might, and this is like a pretty hot code path. Actually, it's only once per chunk instead of per property. So, I mean, it'll probably get a few percent. So yeah, this is kind of a separate optimization on top of this. Is the property descriptors function used at all? Barely. That's exactly what I wanted. Okay. So can we do even better? Prop name. So there's only one usage here. Yeah, so prop name aster into wait, Euster. Oh. Haul up. Haul up. Can I do this better? Haul up. Oi. Okay, so this guy is a canonical property. Do we care if property name is a Euster or not? So this is making it, and then this is using it. Old property name, new property name. Huh? 200 to 400. Add property, canonical property, old property name. That's only used for debug. At this point. Okay, but then what about here? Debug again. Oh. Okay. So literally does not matter. It does have type of database reference. Wait, wouldn't that mean that this could also be database reference? Because it's a canonical property from the database, right? Yes. So you should always be able to get the database reference of the property. Canonical name, Cowster. This is straight from the database. Yeah, no, you should totally be able to do this. Okay, I did not see that coming. That's a kind of separate optimization. So this is kind of a new branch called look up cache or something. And I'm just like doing things. But I can keep doing better on the other man branch number 4. And I can remove it even harder. So it's like this. It's like this guy. So I believe right here we have a db stir, not a Euster. And then that also means that these guys are both stir. And we can yoink a splunky there. And then is name. Okay, hold on. Okay, that's a problem. Okay. Right. Okay, so this is saying This is a different lifetime. Buh. Cow as ref. Prop name. Deserializer. Wait. Oh. Oh, I can do this. Juice? Juice? Are we juiced here? Damn, I didn't realize it used the deserializer lifetime there. That's juiced. Okay, so then this guy wants stir. Stir prop name is string as stir. We can make that nice. Formatting so much. Yeah. Okay, so that avoids creating, let's see. I think there might be a Clippy going on here where it's like doing an unnecessarily conversion, but I don't feel like finding it. Just let Clippy find it. Oh wait, I can find it like this. All up. Go here. References. There it is. Okay, that's the only call site. Okay. Huh. Okay. Okay. I see. I'm picking up what you're laying down. You're. We're going over here. New. Okay, so the return. All. Okay. Remember I said how all paths lead to return? Well, we can take advantage of that. So instead of saying return, we can just say, yes. And it'll just do it. Hello. Okay, so then that goes in an earlier man. Oh. Please spell. And then this one is also gaming. Unneeded. It's more unneeded thing is. So implicit return. Okay, what else, Clippy? You say anything else? Nope, that was it. Okay, so implicit return goes on to this dude right here. And then unneeded same type business on find canonical property. Hell yeah. So what do you think about that? We're gaming. Okay. Should all work. Faster. Oh my god, it's so slow. Nice. That took ages. Okay. It's still going! Okay. So no tests failed. Huge. So I'll keep going. So this is the lookup cache. I'm looking up the cache. This will probably fail, but that's okay. We can... Huh? Oh. Wait. For real? Oh, we want to skip, don't we? Okay, hold on. I'm gonna put up, and then I'm gonna skip it. Skip, and then we gotta do it. Okay. Okay, so we want both of these. We want this guy and this guy, like this. Oh, so we need this guy and we need this guy. Cool. Okay, so this should be very close. Cool. I don't know anything about Rust. Well, good thing I'm the one who needs to know about Rust, and you can just watch. It might not be very interesting, though. It's just like babbling about technobabble. Who knows what any of it means. Okay, so this is nice. Let's go. Let's go. This is so good. Finally a good change. So that might actually provide a minuscule performance improvement because it doesn't need to hash the strings as it inputs them. But it'll be almost nothing. Whereas this, the lookup cache type code. Wait, is that done? Did I actually do the whole thing? Nice. So what is this called? Cache class descriptor binary cache class descriptor in deserializer in type info. This avoids re-looking up the same class. Hooray. How did you learn Rust? So I learned Rust in 2023. Prior to learning it, I had been programming in Lua for 15 years. So I had a lot of programming experience. So if you want to learn programming, it's sort of general across different programming languages. 70% of learning a programming language is just learning programming. And then the 30%, it was much easier for me to learn a new programming language after I already knew programming. But the way to do it is to find a piece of example code that works and then tweak it to do something else, because you can do stuff like, if I change this, then I think it'll like turn red or something. And then it doesn't turn red, or it does turn red, but you've predicted what's going to happen and then observed the output. And then you're either like, yes, that was correct, or no. And then you have to go figure out why. So I think that's the best way to learn programming, is because like you can't start from a blank page. It's so much easier to break it, but then be able to go back to working code, right? Instead of like you have to make something that works perfectly the first time. Like, how? Okay, gaming. Let's see. So, very good. So that is just like that. DB. And then they use it with DE. That is fine. It works. Okay. Yeah. Okay. Let's do a series of benchmarks. So I'm gonna go boom, 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 cargo bench. Hold on, I gotta turn off my video encoding because that's using 100% CPU. Another tip for learning Rust. I watched a lot of YouTube videos, and that I didn't really learn Rust that way, but I learned that the borrow checker exists. I learned that there's algebraic type system. So I sort of got a feel for the landscape of what exists in Rust and what I could go and learn. And then what actually cemented learning Rust for me was the rustlings exercises. So rustlings. No way. So this is like an interactive series of exercises, and the idea is that the code doesn't compile. Oh, you know about it? And then you have to fix the bug. So there's like a bug somewhere in the code, but the compiler will tell you information about that when you try to compile it. And then you can use that information to try and fix it. And it's like, it walks you through all of the different Rust syntax, and you get hands-on experience writing Rust code. So it's good. It's good. Okay. So we're doing benchmarks here. So what I hope to see is that after we do this baseline benchmark, we can do a benchmark on the this PR4 branch, and there might be like a 1 or 2% improvement in performance, but I don't expect much. And then this one I expect to have more like 10% or something. Maybe also like 4%. I don't know. Because it's like, it's per property chunk. It's not relooking up the class descriptor. Or per something. I don't know. Wait, type name. Wait, excuse me, what the actual hell? Oh, no, that's where it does it. Okay, okay. Oh my god, okay. This is an instance chunk. That makes perfect sense. Okay, amazing. Okay, so we did the initial benchmarks. So now we should see almost the same, maybe a little bit faster. Like my way of explaining stuff in a general way. Yeah, I've been streaming for many years now. So I understand that I have to sort of target a lowest common denominator, but then learn about context of who's watching, and then communication requires mutual context. Jokes also require mutual. If you try to make a joke and you don't have the mutual context, it will not land. It'll just be cringe. It's a source of cringe. You want to. More like snap infested waters. Get it? Remind me of Primogen. Well, just because I'm talking about programming? That guy worked at Netflix. I work at my house. Huh? 21%. Okay, that's very different than I was expecting. Oh, you know what it is? It's... Oh, okay, I think what's going on is there's two... There's an unreliable benchmark going on, and it was faster and slower at the same time. Ooh, 6%. Ooh, 6%. This benchmark is unreliable. So I think that it's maybe faster, but the benchmarks are unreliable. So when I run a benchmark and then run another benchmark, run another benchmark, this specific one can be 70% slower randomly. So what I think happened here is that in the baseline benchmark, it was randomly fast. And then in the improved benchmark, it was improved, but it was randomly slow. Undefined behavior. Yeah, type situation. Oh no. Oh no. There's no way that could possibly be slower. Well, I guess it could if it's super bad somehow. Does it still pass tests? I should. It should. Okay, cool. Okay, so now that was not very nice. The randomness factor is really annoying. Okay, let's benchmark the cool people new branch. Oh, I should probably also make sure it works. This is deserialized change and serialized change. So both of them should be faster, but it might be minor. Or it's slower. What? I get nothing out of this? Huh? These are nothing numbers. I guess the property chunks go pretty hard to transpose the properties and serialize them with all the same type at once to deduplicate that information and that work. Guess it's not that big of a deal. Buh. Man. I don't get a 10% improvement. It's so meh. Question though, does it pass the tests? It does. Okay, so that means that the assumption that migrations are always on the same class is valid, at least within this testing framework, within the available tests. Damn. So this is prop chunk get type info. So it just already knows about the class descriptor and doesn't have to look it up again. So that it's not actually that much work that's being saved here. That was disappointing. I don't know if there's any performance improvement at all, or even if it's detrimental. I simply can't really tell. So first of all, the unreliable benchmark got in my way, so I don't really know what happened there. And second of all, when it didn't proc the unreliable benchmark, it wasn't very exciting. It'd be nice to base it off of a branch where this doesn't happen, so I can do like reliable benchmarks. Bruh. Maybe let's just try again. Like if I go like this, it should tell me, oh, master branch is slower or something. If we see any green numbers, then we don't like to see that. I want the new code to be faster. This means that the old code is faster. Why, that doesn't make any sense. Why would it be faster? It's literally doing more work. Bro. It's consistent? How can doing more work be consistently faster? Oh, is it procking the unreliable benchmark? Dude, I have no idea. I have never seen 32% before on the unreliable benchmark. It's always like 0.64, 0.64. So I think there is some kind of something going on, but it's really hard to tell because the benchmarks are so unreliable. Damn. It's 12% faster to do more work. Huh? I guess I'll just try again. But I want to like see them discreetly. I don't know. It's supposed to be faster. I'm just going to try it fully. This is kind of what I expected. I don't know. What was that? I was noises of pain and confusion. Why is it slower? It doesn't make any sense. It's doing one lookup instead of n lookups. Like it's literally hashing like 20 times less per instance type. Is it a okay, I have an idea. I'm going to make a benchmark base branch where the unreliable benchmarks don't happen. It is slower, but it doesn't happen. Okay, so what is it called? Bench base. I forgot. What are you working on? This is the library to read Roblox files. I believe it's this. Read directly. Yeah. Yes, it is. Okay. Okay, so this is now my benchmarking base branch. And then now I make another branch, bench PR4 and merge PR4. And then bench lookup. And then merge lookup. Okay, so let's check out bench base. Benchmark the bench base. We might see it go slower or faster, who knows? And then, but it should be reliable now. Seems to think it's faster. Yeah, I think it was just going randomly faster and slower, and it was messing with the benchmarks. Or maybe it's actually just slower. I don't actually know. You always have to benchmark things to like know for sure. Ugh. No way. Are you making that library? It's an open source library that, yeah, it's a collection of cross-platform libraries that enables software to interact with Rolex instances. That's what I'm working on. So I'm contributing to that open source library. Trying to, at least. Things aren't going my way. I can't seem to get the performance optimizations that I think that I can get. God damn. It thinks it's so much faster. Okay. So let's try this now. Let's see if this gives me some sort of reliable answer. Instead of unreliable. It might still say red numbers. I don't actually know. I don't want it to say red numbers. Don't say the red numbers. Why is there the red numbers? It doesn't make any sense. It doesn't make any sense. Are you having a mental breakdown? I'm having a hard time believing that it's slower. Piece of fluff flying by. 5% slower. Yep. Why? So it's fine on serialization, maybe even positive. Perhaps 3% positive on serialization. But on deserialization, it would appear to be slower. Even though it's not hashing strings into Eusters when it doesn't need to. And not relooking up properties when it doesn't need to. There's no way that the superclass's iter is slow. Alright. GitHub username's Krakow10. Yeah, I wanted to change it for like 10 years. But you can't, so cool. Alright, let's run this benchmark while I'm looking at my Gubert code. What? How does it get even slower? Instead of looking up the class, which requires hashing, it already has a reference to it. It must be the superclass's iter is slow or something like that. I don't understand why it would be slow. Does it, do I want to convert to a stir beforehand? Bro. It's just slower, 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 slower to do less work. So I reduce the workload of the code and it runs slower. Can you see why I'm going crazy? What I meant. Okay, this is ignoring. Hmm. Oh. Wait a minute. This is wrong. Yes, this is wrong, but it's still doing less work. Ah! And why is it pass the tests when it's wrong? I guess there's no invalid properties in the test files. Like, the deal is that the class descriptor could possibly not exist. And that needs to be at the most inner level. What the hell happened to the music? Yeah, this is wrong. Notably, this code is wrong. So this right here, that's what's wrong. I have an idea. Right. Oh no, that's not the right code that's wrong. This is the code that's wrong. Oh, but it needs context to generate a default. Yeah. Yeah, so to do this correctly, it needs to be folded in. I would also make it cleaner looking, so I accept. Ish. So now it's correct. But unlikely to be faster because it instead of throwing away invalid properties, it is now deserializing them. But it should look way more like this. Oh, oops, wrong branch. Yeah, so instead of changing this entire block to be a mess, it just changes this little bit. So I'm thinking that superclass's iter is somehow slower than the loop. The loop. But why? So in the reflection database, oh, it's over here. No, it's not. Where the hell is this function? What? It is there. Okay. This function superclass asref and then classes get. Wait, can I do as dref? Ooh. Can you imagine if that fixes it? See? Oh, it's dirty. Dang. No, we're not getting a clean benchmark out of this. Ugh. I'm going crazy. Is it just because it's like so indirect? It was going through. I don't know. This is yet another tweak. What? Back to the unreliable benchmarks. The speed at which I'm building up pull requests is deeply funny. Oh no, you can't SRF. Come on, bro. Got a blast, yeah. Current class equals while current class. By that, I'm talking about the YouTube chatter. Maybe you are too. YouTube delay is so long. Ugh. That is so brutal. Just S. I'm so mad. I added 2 characters and it's like I hate formatting. Like what else could it be? How could it be slower? It doesn't make any sense. Find map. How does doing less work make it slower? Oh my god, bro. It's this pull request. I don't understand. I don't get it. I don't get it. What does this do? F. Branch. So painful to see it not speed up when it does less work. Hold on. I think I can actually remove this function because there's only these two uses. So I just kind of boink this code into there. We go like this. Boom. Cool. So that completely gets rid of this function. This is still common. Could be like find class prop or something.
Would have to be in the reflection database.
Man. Just don't get it. Minus 27 is a major W. Okay, can I do that same trick here? So this guy only exists if that exists, and then we don't care about anything anywhere else. I think I can. So I think I just kind of go like this, and then like this, and then this code goes here. Except now we can't do this. Right, that's to fold the whole thing into the else. It belongs in like function call type business. Why is it slower? I don't get it. I don't get it. Like it has to what? It has to find Wait. 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 Why are they using a hash map here? What the hell? Oh. Okay, because these stupid things could be in any order. Oh, that's dumb. That's giga stupid. Why is it not implicit? That's so dumb. Wow, that's really dumb. Wow. Wow, that's super dumb. Oof. File format woes. How do you make Roblox's dumb file format fast to decode? Apparently not like I'm doing it right now. Apparently I'm really bad at making optimizations. Apparently I have no idea what I'm doing, and I'm making things slower by reducing the workload. Like, what even can be going on here? Is it all like cache line CPU prefetch optimizations? How would they even be relevant here? It's literally a reference versus a hash map lookup. You already have it. How is it slower? Huh? Like, there's no additional heap allocation or anything. It's all stack goodness. There's like these branches, but like this is way heavier. Before, I don't understand. A voice. Okay, so this is a very cold path. That's like a one of the big optimizations here. I think it's not even getting called at all in this. So this is. really, this should be this code should be a function. This code should be a function. Something here needs to be a function. I'm dying. What the hell is going on? Where is it spending the time? God, like I was in the middle of this thing and I'm like, oh, I have an idea how to make it faster. And it just makes it slower. Spent all this time. This was at 3 p.m. and it's currently not 3 p.m. Worthless hour. I do not understand why this is negative value. This is what is slow in my mind. That's what's going on. I'm trying to do this operation fewer times. Are they using it in the database? Hash map, cow, property descriptor. They are not using it. It's not even a hash. Like a hash is like the fastest hash algorithm for Rust. Is it the fastest hash algorithm period? Well, no. It always depends when it comes to hashing. Hashing is like the ultimate it depends situation. They're not even using the fast hash function. It's like 3 times faster than the standard library. And yet, saving the hashes still doesn't save time. I don't get it. Like the entire reason why I am on this journey of discovery is because I thought I could fix a performance issue. But if it turns out I just have no idea what I'm doing, then what's the point of acting on something that I think that I know a way to improve performance? Clearly, I just don't. I don't trust anything. something somewhere has conflicting information. I don't know if it's in my head or if it's on the code that already exists. If the benchmarks are unreliable. Well, my history of finding performance optimizations is not flawed, so I would like to think that it's not me. Does it need a goddamn like inline or something? Because man, I just don't know. Like, is this like cross crate compilation problem where like it's going back and forth across crate boundaries, and it can't optimize the loops, the iterators into like optimal code? Because like iterators are very complicated. So maybe it is this thing, and it literally just can't cross the crate boundary. Let's see. Let's go with this. Everybody gets DB. All right, what do you think? So who was benchmarked last? Who's going? What's going on here? All right, so let's. So I benchmarked it. I don't know. Whatever. Just bench it. Oh great. Ooh. Ooh yeah. Doesn't like this guy. What? Oh, database got longer. Doesn't seem to be making a difference. I don't really have a good concept of the gains for optimizations and stuff, of like what is like an optimization that's like 1 nanosecond, what's an optimization that's like 1 microsecond, what's an optimization that's a millisecond. Like I just see something and I go, oh, that would be faster. I don't think that would be 1 millisecond faster, or that would be 1 nanosecond faster. It's mostly just this is less work. This code path is less work. I don't understand. How is following a reference slower than hashing? Which includes following a reference. %4. Wait. Okay, I'm not running the encoding. This is brutal. I just like don't really feel like I know what I'm doing anymore. It's really lowered my confidence to make an intentional change and have it completely backfire. Really thought I was onto something. There's no end in sight. This is just like not even close to being done, even though it compiles. Okay, I think I should just stop. It's not good brain time. It is currently bad brain time. I'll try again tomorrow. I just keep scouring my brain to try to like understand how it could be slower. But like, it's doing a subset of the other operation. I think that's the only difference. Grasping at straws. How could this possibly be? You get the mesh thing? No. I might do that today anyways, if I hear back from that guy. Like this. That's very irritating. Well, I'll take another stab at it tomorrow. I made exactly the progress that I wanted to make, but it really, it's another like stuck point, which is the same as what I was doing over the weekend. I was like working on this over the weekend, and like biting off a chunk, doing it, biting off a chunk, and doing it, and I just did the same thing today. And made a piece of progress, but now I've made enough progress to see the bigger picture, and I went, oh, that's a lot of work, and then I went off on a tangent trying to optimize something, and it didn't work, and that just depressed me. So I think I'm done. I'll be back tomorrow. I'll do another chunk of work and probably look at the optimization stuff again. I'll see you later. Goodbye.